Alright, hello. Um, I'm in an airport right now, so I am not able to be there with you on this lovely day after the break. And I'm going to make this video for you, going through this lesson while strangers in the airport look at me while I talk to myself on my headset, but that's okay because I'm never going to see them again, so what do I care? Alright, in our final unit for this semester, it's so exciting. I'm so sad I'm missing this day. Uh, I'm going to be throwing a lot at you here, but just try to manage it. Just try to understand bits and pieces, and if you don't understand everything, that is okay. We'll get there when I get back. So first we need to understand some terminology here. So let's talk about a circle. That is the main shape of this unit. So if you take a circle, and you can draw one over here, and you have to put up with my junky mousepad smartboard techniques here. If you have a circle, the radius, and I probably don't need to tell them any of this, the radius is from the center of the circle to the edge. So you could say that the radius is a line from the center of a circle to a point on the circle. I don't really care about the formal definition. It's much more useful to understand and to be able to visualize it and picture it. So that would mean the diameter of a circle is, if the radius is there, the diameter is actually double the radius. So it's basically, double the radius. But I guess a more correct way to describe that would be to say that the diameter is a line, how should we say this? It is a line between 2 points on a circle that goes through the center. That's probably how I would describe it. So I've got 2 points on a circle, point 1 and point 2, and they go right through the center of the circle. A chord is pretty easy. A chord is kind of like the diameter, except it doesn't go right through the center of the circle. So if I draw a circle, a chord is any line that connects 2 points on the circle. So there's a chord because it goes from this point of the circle to that point. This would be another chord because it goes from this point of the circle to that point. It doesn't have to go through the center of the circle. So we can just say it is a line between 2 points on a circle. And a secant is kind of like a chord. However, if you were to draw a secant, it is a line that goes through 2 points on a circle. So very much like a chord, except it goes straight through. It's like an arrow being shot through the circle. So you could say a line that goes through 2 points on a circle. And the last one we have here, I think we got a few more, except my text is ruining things here. The tangent, if you draw a circle, is a line that is outside of the circle and it only touches the circle at one point. So like that. So hopefully you can see that this line goes through exactly 1 point on the circle. This is not a tangent because it goes through 2 points. Oh god, there's an announcement going on in the airport. Hopefully you can't hear that. So you could say it is a line that touches a circle at exactly 1 point. Because this line outside the circle touches that just 1 point of the circle. And finally, I'm just going to erase some stuff here so I can get this last point. The point of tangency. Well, that's just the point where the tangent touches the line. So if this is our tangent line, the point of tangency is that point where it's touching. It's that point right there on the circle. So it's just the specific location that that tangent line touches the circle. So you could say it is the point where the tangent line touches the circle. There we go, that's easy. So knowing those definitions, let's just complete this diagram here. So the center O is the center of the circle. So they're telling us the center is denoted by the letter O, so you can just put an O right there. Label the chord XY. Well, a chord is a line that touches 2 points on a circle. So the only chord I see here is this line right here. So if we're naming the chord XY, that means it goes from point X, so this point right here, to point Y, that point right there. The tangent AB, well, the tangent is a line that's outside the circle and touches the circle at 1 point. So if we're naming the tangent AB, that means the tangent goes from A to B. And the point of tangency, so that's referring to our tangent line, the point of tangency is right where that tangent line touches the circle. So that point P is right there. Draw in a radius and label it OC. So radius is from the center of the circle, so this dot, and to any point outside, or any point on the circle. So as long as you start from the center and touch an edge of the circle, you've drawn a radius. So it goes from O to C. So O is right here, so this point must be C. And draw in the diameter and label it DE. So we can draw in a diameter. A diameter starts at any point outside the circle, and as long as you go right through the center and touch the other side of the circle, you have a diameter. And they want us to name this diameter D to E. So that means this point of the diameter is D, and that point is E. So just putting our new definitions to use and also labeling these lines, which is an important part of this unit. One last thing, if we scroll down, I believe we have this diagram. Much the same, a couple new terms here. So label the center O. Well, the center is the center of the circle, so it's that point, and they want us to name it the letter O, so put a big O right there.
Over here.
Then they want us to draw in a central angle, and a central angle is AOB. Okay, not a big thing to worry about. A central angle is an angle that is, you guessed it, at the center of the circle. So an angle, you just draw two lines like that, and now you've drawn a central angle. that angle right there, that's an angle. Oops, there goes my keyboard again. So if you wanted to name this angle, it goes from A to the middle of the angle to B, also the vertex. So A, O, B. The only thing you need to remember is that middle letter, O, that's the vertex of your angle. That's basically where the angle is. And then the outside letters, A and B, are just the outside points. Alright, pick a point on the circle and label it Y. Alright. Nothing up here, let's put a point right there and let's name it Y. Draw an inscribed angle. Inscribed angle. So a central angle is at the center of the circle. An inscribed angle is any angle inside the circle. So, what you can do is you can draw this inscribed angle like this. So an inscribed angle XYZ. So remember that middle letter is where the angle starts, or basically the vertex of the angle. And then X and Z are the endpoints. So there's an endpoint X and there's an endpoint Z. So you could literally draw any angle on the outside of the circle for an inscribed angle. The central angle just needs to be at the center of the circle. And lastly, the arc. So the arc AB, arc refers to the actual circle. It's the part of the circle that goes from A to B. Well, here's A and here's B. So the shortest distance from A to B is right here. So we would say that that is arc AB. Similarly, arc XY is the shortest distance on the circle from X to Y. So if X is right here and Y is right here, the shortest distance from X to Y is right there. So that's arc XY. I'm reluctant to try to write that with my mouse right now. But honestly, it's not too bad. Throwing lots of terms at you for this intro lesson. As long as you understand a bit of it, that's okay. I'm happy. Alright, next page. Flip over your page. Tangent property 1. So the first tangent property, remember what a tangent is. It's a line that touches the circle at exactly one point. Right there. When two lines meet at a right angle, 90 degrees. So hopefully you guys know that a right angle is that angle. And it's often denoted by this little square. That's a 90-degree angle. When two lines meet at a right angle, they are perpendicular. So these lines are perpendicular because they make a right angle. The point of tangency is where the circle meets the tangent. So I actually already drew the point of tangency. It's where the tangent line meets the circle. Draw a 90-degree right angle from the point of tangency through the circle. Use your protractor. Let's not bother with a protractor. I don't even need a protractor because if I draw a 90-degree angle from the point of tangency through the circle, so I'm starting at the point of tangency and I'm going to draw a line through the point of the circle like that. So in other words, I just drew a diameter. Same thing on this circle. The point of tangency is right where that tangent line hits the circle. And then you draw your start at the point of tangency through the center. So not here, not here, not here. It has to go through the center like that. Point of tangency right here, through the center circle. Point of tangency right here, through the center of the circle. So what's the relationship here between a line that starts at the point of tangency and goes through the center of the circle? Well, it forms this angle. It forms this 90-degree angle, right? There is a 90-degree angle right there if you've drawn it properly. There's another 90-degree angle. That angle's 90 degrees. This angle's 90 degrees. So no matter how you cut it, you get 90-degree angles. And we know that if two lines make a 90-degree angle, they are perpendicular. So, scrolling all the way down, what have you discovered? Well, you can say that a line starting from the point of tangency through the center of a circle is perpendicular with the tangent. Perpendicular. I never like words in math. I always just like pictures, and understanding the pictures is more important to me. So that's the pattern there. You've got these two lines are perpendicular if you've drawn them properly. All right. Another tangent property. Draw a point outside the circle. I know how to do that. That's pretty easy. Here's a point. Draw two tangent lines from that point to the circle. Okay, that's a little trickier, but I think I can do it. So I'm going to start. This is really nice if you have a ruler. I'm going to start at my point, and I'm going to draw one tangent line. So as soon as the line touches the circle at one point, ooh, boom. That's a tangent line. But I need a second tangent line. Alright. So I'm going to start at that point, and I take my line, and as soon as it touches the circle, boom. There is a tangent line. So for good measure, I can say the point of tangency is right there, and the point of tangency is right there for both of those lines. Measure each tangent line to the point of tangency. Okay. Wording's a bit weird, but I think I know what they want me to do. If you take your ruler, and please forgive me, I'm going to erase some stuff because this is going to be impossible if I don't. So if I take my ruler, and start from that point that I drew and up to the point of tangency, so that point right there, this is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. Let's call it 4.5 centimeters. Looks like 4.4. We'll call it 4.4. From this point to the point of tangency was 4.4 centimeters. And I'll save us all the trouble. I'm not going to measure that line and do that. That was just too painful. But same thing from here to here is 4.4 centimeters. So you just have to take my word for it. You can use your own ruler if you don't believe me. So what do you notice? Well, they are the same length. They are equal. And the second point here, if two tangent lines meet at an external point, what do you know? Well, that's just what we just discovered. I have two tangent lines, and they meet at the same point. They're the same length. So, I don't know, this is kind of a redundant point. You could just put, they are the same length. And scrolling down, let's put some of these theorems to use. So here's our diagram. Point O is the center of the circle. Point O is the center of the circle. So the center of the circle is right there. And AB is tangent to the circle. AB is tangent to the circle. So here is A, and here is B. So they're talking about this tangent. In triangle OAB, so that's referring to the entire triangle OAB and its three vertices. Angle AOB is 63 degrees. So remember what this means. O, the middle letter, is where that angle is. So that's that angle right there. And it goes from A to B. Those are its endpoints. So AOB. So that angle right there is 63 degrees. Determine the measure of OBA. So angle, that little symbol means angle. OBA. So the middle letter is the angle where the angle is. So it's not at O, it's not at A, it's right at B. So that angle right there. What is the measure of that angle? Well, hopefully you guys know that in every triangle, there's 180 degrees between all the three angles. So if you know this, oh, this is so painful. If you know there's 180 degrees in every triangle, you can use that to solve this question in conjunction with one of the theorems we just learned. What's this angle right here? What is that angle from a tangent line to through the center of a circle? That goes back to here, right? That's that 90-degree angle. So the question doesn't spoon feed it to you. You have to realize that this angle is 90 degrees. So if you know this angle is 63 degrees, you know this angle is 90 degrees, you can find that third and final angle. How? Well, you know there's 180 degrees in every circle. So if I know two of the angles, I just subtract them from 180. So I can subtract 90. I'll subtract that 90-degree angle. And I will subtract the 63-degree angle. And if you get your calculator out, you should find out that that final angle is 27 degrees. So, I'll try to make this look nice. Equals 23. So that angle right there has to be 23 degrees. Has to be. There's no other way to cut it. Alright. This is literally the exact same thing as the first thing. Draw a line from the point of center to the point of tangency and measure the resulting angle. Use your protractor. Or we could just use our brains. So if you want to draw a line from the point of center to the point of tangency, here's the center, here's the point of tangency, draw a line. What is the resulting angle? Well, it's that angle right there. We know that the angle's 90 degrees. Let's do it one more time. Draw a line from the point of center to the point of tangency. Use a protractor to measure that angle, or just use your eyes. That angle looks like a 90-degree angle. What have you discovered? Well, the exact same thing we already discovered. A line from the center of a circle to the point of tangency is perpendicular with the tangent. That's what I would say. That's what we already said. So let's just go in the opposite way of what we did last time. Last time we started at the point of tangency, we went to the circle at center. Now we're going from the center out. Okay, 3 questions on this last page. Let's do 2 of them. And let's do the last one first, because this one is actually the easiest one, I think. Determine the distance between the points P and the center of the circle with a radius of 5. Okay, couple pieces of information here. I know that a radius is from the center of a circle to the edge of a circle, like that. Boop. So this radius is 5 centimeters, I'm assuming. And every radius you draw will be 5 centimeters. So that radius to that point is also 5. But that's not what I'm trying to find. I'm trying to determine the distance between points P, so point P is right here, and the center of the circle. So the center of the circle is right there. So I'm trying to find the distance of this line. So you see I've created a triangle. And not just any triangle, I've created a right angle triangle, because I know that that angle is 90 degrees. Because we're going from the center of the circle, and this line is tangent, so we know that that angle right there is 90 degrees. So if I may, some of you will see where this is going. Come on, give me blue. I'm going to take this triangle out. So I've got that line, and then I've got the line P, and then I've got the radius here, like that. This is a right angle triangle. I know this length is 5. What's the length of this blue line? Well, the length of this blue line, if this line's 10, we learned from our first theorem that if this side's 10, this side also has to be 10, because both of these lines are tangents and they touch the same point. So this is 10. So how do I find that line, the length of that line? Well, we got to use a little tool called Pythagorean theorem. And Pythagorean theorem, you guys have already done before, not in this course yet, is a squared plus b squared equals c squared. And the only thing you need to be careful of is c is the hypotenuse of the triangle. It's the longest side of your triangle. It's the side that is on the opposite side of your right angle. Doesn't matter what you call A and B, but C has to be the longest side of your triangle. It has to be that hypotenuse. So if I want to find c squared, well, I can say that A is the blue side, because that doesn't matter. I can say that B is the red side, and I can say I'm trying to find C, the hypotenuse. So A squared, A is 10, so I've got 10 squared plus B, B is my 5 squared equals C squared. So 10 squared is 100, plus 5 squared is 25, equals C squared. So I've got 100 plus 25 is 125 equals C squared. But I'm not interested in solving for C squared, I just want C, so I need to get rid of that square. And the opposite of squaring something is square rooting it. So if you square root both sides of that equation, you'll end up with C. So the only part you need your calculator for in this question is finding the square root of 125. I get 11.18. And that is the length of that green line, 11.18 centimeters. So determine a distance from P to the center, that was this line, 11.18. Okay, can we do one more quickly? Let's do the first one. It's the exact same thing. Let's do it quickly so you guys can stop listening to me. Point O is the center of the circle, so there's point O. And CD is tangent to the circle, so from C to D, that's that line right there. Oop. CD equals 15 centimeters, OD equals 20, so 15, 20. It's all labeled for you, perfect. Determine the length of the radius from O to C. So OC is from O to C, so that's this radius. Well, once again, all you need to realize is that you have a right angle triangle here, because the angle of this tangent to the center is 90 degrees. So if you take that triangle out, it looks something like that, where the right angle is right there. This is 20, this is 15, and you're trying to find OC, so that's that side of the triangle. Pythagorean theorem again. A squared plus B squared equals C squared. All that matters is your C squared is the longest side of your triangle. It's the side that's opposite of your right angle. So that's this side right here. So this time we know C squared. We know C is 20. A and B, it doesn't matter. Call this side A, call this side B. Does not matter. A, we don't know, so I'm going to leave it as A squared. Plus B squared. B is 15, so I'm going to put 15 squared. Okay, what can I solve here? Well, A squared I'm just going to leave because I don't know it. 15 squared, I can punch that into my calculator. I get 225. 20 squared, I can punch that into my calculator. I get 400. And how do I solve for A squared here? Well, I want to solve for A. I want A. I don't want A squared plus 225. So I got to get rid of this, and I got to get rid of the square. So using our reverse BEDMAS, it tells us to get rid of that plus 225. And the easiest way to get rid of plus 225 is to subtract 225. Boom, it's gone. Whatever you do to one side, you got to do to the other. So I got a minus 225 on the other side of the equal sign. So now I'm left with a squared equals 400 minus 225, which is 175. Now this question looks the exact same as this one. I want a. I don't want a squared. So how do you get rid of something that's squared? Well, you square root it. Boom, they cancel each other. Whatever you do to one side, you do to the other. Unfortunately, I do not know the square root of 175 off the top of my head, so I'll pull my calculator out, and I get 13.23 centimeters. So that is the length of that side. 13.23. Give this one a try. It's a lot of words, but really all you're trying to find is that length. So you don't even need to really bother with the words. Easy peasy. Okay, not easy peasy, sorry, that's rude, but very similar to these two questions. And give a couple of these a few tries. Especially the first ones, because that will just reinforce the naming conventions and the terms we learned today. Okay, thanks for listening. I know it's tough listening to me on a computer, but I'll be there tomorrow.